exercise 1. Our question is there, 13th one. In the exercise 1, given a non-empty set X, non-empty set means they have some element, they are not a null set, and binary given Px cross Px tends to Px, we defined as this binary is your given that A binary B, A minus B union B minus A, that is the main step for AB belongs to Px. So show that empty set, null set, this null set is your identity for the binary, and prove that also A inverse equal to A, that is your invertible functions. Very easy. First of all students, I explain you related your identity function. Yes. Suppose you know the property, first of all our identity. Suppose E is identity for binary. So what is the property? A binary E, E binary A is equal to what? A. Yes, here I am proving E is what? Null set. So very easy. These are start now. For E is equal to null set, I just explained A binary null set. Yes, apply here. A binary be given, then apply here A binary null set. So A minus null set union null set minus A. Now what is the A minus null set? A. Here null set union A. Check. You validate the RHS. If you validate, then sure null set is your identity. Same I checking now. Second property, E binary A. It means null set binary A. And this null set binary again apply here. So null set minus A union that A minus null set. Yes. So similarly students, I checking the second rule, null set minus A, which is null set, and union A minus null set is A. So what you get answer? A. Check. In the both cases, this property is proved. That's why I last telling A binary null set and null set binary A, which is A. Therefore, this is proved. Therefore, what I write? Null set is our identity for given binary. Now, secondly, I am going to that one. It is an invertible. So, property for invertible. Yes. Suppose here, assume that suppose A inverse is invertible for given binary. So what is the property? A binary A inverse I inverse. A inverse binary A is equal to must be coming. What is must be coming? Identity. It is E. And E equal to what you are getting? Null set. I just check out. It is true or not. A binary A inverse. Here I am taking A binary equal to A, proofing, na? Here I am taking that A. So A binary A, I just checking in this two. A binary B, no A minus B. What I here written? A minus A. This one, union A minus A. Null set, union null set. It is null set. Check. It is true. Yes, true. Same as I second case apply. A inverse binary A. Again A binary A. Here taking A inverse is A, huh? Yes, rule is same. Same result coming. It means confirm that this again the property is done. So this A inverse A already I apply here. It is valid. So lastly we can say A inverse equal to A is true. It is an invertible function for your given binary. Now I am going to 14th question. Now students, slowly same going. Question 14. Define a binary operations on a set 0, 1, 2, 3, 4, 5 as an element as A binary be given A plus B in regarding A plus B less than 6 and A plus B minus 6 is A plus B greater than or equal to 6. Then show this shows that 0 is your identity and our invertible, it is 6 minus 8. It is inverse functions. Very easy, students. The same concept I applying to first of all your 0 sides for identity. So similarly explain. Suppose E is identity for given binary. What is rule? A binary equal to E binary equal to A. So same concept apply here. A binary E. What is A binary E? According to A binary B, yes, these and these are equal to D. These and these operate now. A is same, B is E. Apply here. So A plus E is equal to A. Cutting, A is equal to 0. Yes, we not operate this one. Because I proved that 0 is under the 6, not above the 6. So only here, therefore 0 is identity for given binary. You same as checking if you A binary A, then also you write down E plus A, E is equal to 0. Finally, this case is easily done. You have to identity. Now I am going to invertible. So say, suppose A inverse is invertible of given binary, either inverse, as you write down, inverse of binary. So property is what? A binary inverse, A inverse binary A is equal to identity. And what's your identity? Which is 0. So here I write down 0. So start now. A binary A inverse, yes students, is equal to E 0. This case apply here and here. In both cases I just apply that value one by one. So what is A binary A inverse according to that? Here A plus A inverse is equal to 0. And second here similarly A plus B means A inverse, minus 6 is equal to 0. So what is getting here A inverse? Minus A. That not valid to our conditions. Yes, so these are not taking to answers. Here your answer. Check. A inverse is equal to what? 6 minus A. And that is your proving that 6 minus A, which is your inverse part. Yes students. And similarly, if you obtain this one, A inverse binary A is equal to E. Same concept. There is nothing that here apply. A plus B minus 6. So A inverse plus A minus 6. So what is your A inverse? 6 minus A. Means either you utilize this case, either that case. Your answer is must be 6 minus A is our inverse part of given binary. Yes students. Now by going ahead, next question. Next students, question going ahead, question 15. Let A side given minus 1 0 1 2 and B 4 minus 2 0 2 and fx in Gx both A to B remain, and fx also given that x square minus x, and Gx given I have to do modulus x minus half minus 1 for every x belongs to A. Then check that both functions are equal. This equal, justify your answer. When both functions are equal students, if you function f and g, again, if you function f and g, both domain same and both range same, then the function are equal. Again repeat. If you function are equal proving, either checking, you necessarily check both domain same and both range same. So very easy, both domain already given here same A, I checking that range. Yes students, so for f function A tends to B, I have to fx how much? X square minus x belongs to A, and my domain is A given minus 1 0 1 2. Apply that minus 1 square including minus 1. Here 1 plus 1 you getting 2. Same 0 apply. It is nothing. 0. 1 apply. You get C0 is 0. And last 2 apply. So what you get? Range? Yes. Range RF. You easily did here 0, 2. Now GXR. Same start to range according to my domain. So now I am going to G function. In A to B, what's my Gx? 2 modulus x minus half minus 1. Domain C in A. A is known. I G of the minus 1, G of the 0, 1 and 2. 1 by 1 apply that. So here 2 in modulus minus 1 with minus half. How much is this? 1 and half, 3 by 2. Modulus remove. You getting just 3 minus 1, it is 2. Yes students, same as 0 apply. Similarly, you can go ahead and use half. And my answer is what? 1 minus 1 is 0. And same as 1 apply. 1 minus half. It is how much? Sorry, 1 minus half. Minus 1 remaining. So here 2, it is half. Minus 1. They getting only must be here 0. And last case, 2 applying. So 2 modulus, 2 minus half. Finally, you done. 2 minus half. 4 minus 1 is 3 by 2. Minus 1. How many? It is 2. So what is the range? My range of G is also 2, 0, 0, 2. We write only without repeating. 0, 2. Check this range. This range, same. Yes. So last you write down. I write down here after that. Therefore, domain of F, domain of G. Already same given here A and B. And what you last? Range of F equal to range of G, which is 0, 2. Therefore, we can check F and G are equal. Therefore, F and G both are equal. And here students, you ending. If your range is not same exactly, then it is not equal function. Yes students. Now I going next question number 16. Now students, we going to question 16. Let A given 1 to 3. This is an MCQ type question. Then number of the relation containing 1, 2 and 1, 3, which are reflexive, symmetric, but not a transitivity. Yes students, which are reflexive, symmetric, but not transitivity. So first of all students, I explain only A cross A elements. Then we can show it properly relations. What is A cross A? 1, 2, 3 cross 1, 2, 3. And go ahead to our both of the cross multiplications. It's simple. So, how many elements are there? 1, 1, 1, 2, 1, 3, 2, 1, 2, 2, 2, 3, and last 3, 1, 3, 2, 3, 3. Yes, students, this related I just checking out to 1, 2 and 1, 3. Our applying to. First of all, I check reflexive 1, 1, 2, 2, 3, 3 was we taking. So we taking relation R. In regarding reflexive, you must be take 1, 1, 2, 2, 3, 3. That's your reflexive. Now symmetric wise 2, 1, 2. So 1, 2 symmetry, definitely you taking here 2, 1 and 1, 3. You definitely taking 3, 1. Other number we cannot take out that. This other number 3, 2, 2, 3 we not taking. Only here 7 elements. Because I checking only 1, 2 and 1, 3 wise. And also not transitive. Okay, I start the first reflexive. Reflexive wise, only checking 1, 2, then your one number is 1 relation 1 belongs to R, 2 relation 2 belongs to R, And also, if you take it 3, then here 3 relation 3 also in R. All are the present. I already taking them because I check how many validity to number of this type of relation. After that, yes, I check into symmetric. Now what is the symmetric relations? If you check in here, according to that, 1, 2. 1 relation 2. So 1, 2 belongs to R. Same, 2, 1. 2, 1 belongs to R. This is only valid according to your 1, 2. If I check 1, 3 wise, then also 1 relation 3 belongs to R and 3 relation 1 belongs to R. I think you think about, sir, you already take here and here checking. What do you check? Yes, students, I check that symmetric or not, reflexive or not. Now you understood, not transitive. So here, students, transitive, very easy. Transitivity we are checking according to this R because they are not same number taking. 1 relation 2 belongs to R. Now next afterward, 2 relation you taking 1. You never take 2, 3 because you are not given. Yes, that's why I am only taking this number. I not take here 2, 3. Okay? So here 2 relation 1. 2, 1 belongs to R. Surely 1 relation 1. Because A to B, B to C. Then you check A to C. Yes, students, this A to C, if you taking, then your number is 1, 1 belongs to R. It is our transitivity, but I check not transitivity. Okay, one more I checking, don't worry. Now I am thinking about two third rules. 2, 1 and also 1, 2. Either 1, 3 and also 3, 1. If I taking 1 relation 3, then 1, 3 belongs to R. 3 relation 1, it is 3, 1 belongs to R. So, definitely 1 relation 1 again. That indicate our what? Transitivity rule. But my solution is not transitivity. So, which element is not a transitivity element? Yes. For element, these are the element are remaining 3, 2, 2, 3. If I am checking here, then that is not a transitivity. Yes, students, just I checking to here. 1 relation 2. Yes, it is belong. But now if you 2, 3 taking them, 2, 3 not belongs to R because that not my questions to checking. And it means indirectly telling about 2 and 3 not valid. So we cannot check here 1, 3. After that, this relation is not possible. Same as also students, if you take into one more numbers, if I 1 relation 3 belongs to R, but we cannot check 3 relation 2 because here not a transitivity. Finally, only this relation is valid to our reflexive, symmetric, but not a transitivity. Yes, students, these elements are not applying in this case. And that type of how many numbers? That only 1 numbers. This is your 1 relation. And that relation 1 I just show you here. And students, here this question is done. Yes, same parallel questions. One more I explain you after that these questions. Now students, continue same questions. Sir, they given 1 to 3. And asking how many number of equivalence relation containing 1 to only. This time only 1 to printed. In previous sum 1 2 and 1 3 both printed. So students, here same I am going to only 1 2 regarding. And equivalence means what? A function must be reflexive. It is symmetric. And sure, it is transitivity. And then we can say equivalence relations. So 1 to number wise, I only explain you that types of first of all relation are. Students, here before relation my mistakes. I first showing to A cross A. You easily understood what I did in here. in the how many number of relation is valid in from regarding A 1 2 3 cross 1 2 3. So what is the number? 1 1 1 2 1 3 2 1 2 2 2 3 3 1 3 2 3 3. And which are the equivalence cover? Yes, these are equivalence cover 1 1 2 2. I not write down 3 3 because I check only 1 2. If you return that, don't worry also. So what is the relation R? 1 1 1 2 1 3. Sorry, 2 2. And here 3 3. Okay. And after that, second check is symmetricity. So symmetric wise is also checking like just I apply 1 2 then 2 1. Yes, we not write down 1 3. Yes, we not write down 3 1. I not write down 3 2. I not write down 2 3 because I only containing 1 2 and here finished. So first of all, I start this solution to how many numbers. So for reflexive, students reflexive wise 1 relation 1 belongs to R. 2 relation 2. Here finished. If you checking 1 2 only, 1 use, 2 use. If you 3 use it, then don't worry, it is true. But according to your question, how many relation is valid? 1 2 containing only 2. Same as students, I explain now symmetry. 1 2 containing 1 relation 2, then 2 relation 1. Already I mentioned that this is only one case. Same as I just if you start 2 relation 1, then also it is 1 relation 2 valid. Already take here 1 2 2 1. This is the second case. Here also students, there are 1 and 2 relation exist according to symmetry. And third, transitivity. Yes students, here also transitive rule I just show out to containing 1 2 only I explain. So 1 relation 2 1 2 belongs to R. Now second what you taking? 2. You have to take it 2 1. No more than 2 3 and other numbers. So here 2 1 necessary write down 2 1 belongs to R. So what you check? A to B, B to C, necessary A to C. So here 1 relation 1 1 belongs to R. Yes, it is symmetry. Same as this is the first case. Second case also valid. If you start in 1 2 place, you start the 2 1 2 relation 1. Same 1 relation 2 because if you started 2 ending 1, now and starting 1 ending 2, that is also 1 2. And last of the 2 2, you also checking 2. This your R. Yes, here also students. It is saying dot. What? It is transitive. Sorry, here by mistake I written symmetric. It is transitive. Here also it is transitive. Students, here also there are two case value. So finally, how many number of these symmetric, reflexive and transitivity? Then it is equivalence. Therefore, there are two. These two. Our this type of relation, reflexive, symmetric and transitivity both, it is your two equivalence relation. And here students, this is our question 17 is easy. Ending then. Now students, same is going to one more MCQ. 18th one. Let a function have R to R. And function is given, it is a signum function. You know that signum function range -1, 0 and 1 to related here x greater than 0, x equals 0 and x less than 0. And another function given also, that is the gx, is also greatest integer function, gx in this integer function. and that indicate what? Greatest integer value that equal to x. Then, does the asking FOG and GF coincide? Coincided means these both values are same in this range belong to 0 to 1. Very easy, students. First of all, I go into our fx function 1, 0, minus 1. X greater than 0 equals 0 and less than 0. Students, this greater than 0 means more than 0. Right? Yes, more than 0. Value any you take, your answer is must be 1. It means 0 0.1, 0 0.2, 0 0.3, any. Same as here, below 0 means minus 0 0.1, minus 0 0.2, minus 0 0.3, any. Left side, the answer is what? Minus 1. And gx given, we have to integer function x to greatest integer less than or equal to x. Here answer, students, must be integer answers. So I start first of all only FOG value. Yes, students, my FOG x, which is f composing gx. It's very easy question. This your integer. Now here integer value I operate to more than 0, less than 0 and equal 0. 1 by 1. Here look, students, it's not easy. You properly listen here. These are 0. Here some number. This 1. I just explaining between that these all numbers. First of all, between 0 to 1 between is all number. Just like you operate integer value more than 0, 0 0.1, answer is 0. 0 0.2, answer is 0. 0 0.3, answer is 0. Other 0 0.8, answer is 0. If you getting till up to 1, 0 0.99, also answer is 0. Yes, it means what? More than 0, but till up to 1, not 1, till up to 1, your answer is must be 0. So here there are first answer. This answer is 0 between 0 to close bracket 1 here open bracket. Only 0 is if you including integer functions, your answer is 0. But other is also that 0 to 1. It means in this case, any number you checking down to more than 0, this one, I operating answer is 0. Now after more than 1, yes, here all this value, I operating to gx this value, and the outside f is same. And that answer is your, students. I just my mistake there. These are the 0 for the particular 0 value. And after that I am taking to x equal to 0 and x less than 0, 1 by 1 case, students. So students, here my mistake I written f. This answer is correct here 0. Now if you further going after that 1, surely you have to this condition, that is 1, x more than equal to. And this answer if less than type, it is sure x less than 0. It is same as you taking your negative numbers just like minus 0.1, minus 0.2, minus 0.3, you getting answer is what? Minus 1. Yes, according to that. This value to you getting only FOG. Now students, I am going ahead to second GUF. It's same as G composing fx, but fx I know in these three cases. So one by one I applying to fx. It is 1, either it is 0, either it is minus 1. For particular conditions, I just write down here. This case are given greater than 0, equal 0, less than 0. And here students, this answer you put down in your GX. So your integer 1, integer 0, integer minus 1. What is your answer? 1, 0, minus 1. Now check. In that particular range, in this answer 0 to 1 is coincided. 0 to 1, what is 0 to 1 answer here? 0. And here 0 to 1 answer is a 1, no? Because it is more than 0. Equal 0, less than 0. So finally students, I write down this answer. So in x belongs to 0 to 1, What is your answer to FOGX? Yes, FOGX is answer. In that 0 to 1 range, it is ZQ. And here, GOFX is what? 0 to 1 means more than 0 units. This answer is what? 1. So, it is not same. That's why we write down these both are not coincident. Therefore, FOG and GOF are not coincide. Coincide in value for 0 to 1 close bracket. Here students, coincide is nothing. We checking that there are two same or not. Now students, after that I am going to last MCQ for this chapter. It's very interesting. Number of the binary operation regarding asking A comma B. Option given 10, 16, 28. So students, I just check here. It is set A. And you know that binary operations must be show A comma A. You just getting total number of the elements. Easy. What is A comma A? A cross A, B, and B. There are 4 elements given to A cross A. Therefore, total number of binary have each elements are such that 2 raised to and total how many? 4. It is 16. This numerical is done. But I give you one extra sum. Very easy. If you written if you A, B, C, just like 3, then how much A cross A? Yes, ABC cross ABC. You getting 9 elements. Just like that. AB, AC, BA, BB, BC, CAC, BCC. So how many here? Total number of binary elements? Yes, very easy. Here 2 raised to 4 because these 2 I just given here 2 elements. Here how much? 3. So you write down 3 raised to 9. If you given here 4 elements, you write down here base 4. And total you cross write down upper way and then get to final 3, 9 times. And students, here our this 90 questions is also happily done. Yes students, in this chapter, illustration to self itself. I mean, you self calculate. If you have other doubts in the illustration, you direct me, inform me in your WhatsApp. Already I given this WhatsApp number. Okay? And here students, our chapter 1 is ending. Now I am going to our remaining questions to your derivative related questions. Okay? Bye bye. See you.